Hello students. Okay, fine. We studied what is acid, what is base, what is salt. We know an acid and a base give me salt. An acid can give me an H plus ion, a base can give me OH minus ion. Fine. An acid can be weak and an acid can be strong. A base can be weak and a base can be strong. Okay, fine. But can somebody tell me where is acid? Where is base? Where is this salt? Everybody is pointing out, don't do there is an acid over there is a base over there, but I can't see it. Where is it? Look around. Can you see the change on the slide? Oh, acid, base and salt is everywhere. Everywhere. That's what we are going to see. It's in the food that you eat, the cold drink that you drink, the substances that you use. It's in the organic world, it's in the inorganic world. Simply, acids and bases are everywhere. And if acids and bases are everywhere, and if they happen to react, then salt would also be around, isn't it? Let us try and study about them in this module. Let us see where everywhere means where do I find those acids. Look at the picture. That picture shows vinegar. Do you remember where you use vinegar? No? Sure? I'm sure some of you would be having a bottle of vinegar hanging around in your refrigerator because you use it when you cook something hakka. Hakka noodles, Chinese. They do add vinegar. What is vinegar? Chemically, vinegar is acetic acid. It's a weak acid. Acetic acid. Okay, other than that, where is vinegar used? Fine, I use it to make Hakka noodles to give me that flavor. But where else is vinegar used? It's used in the rubber industry. It's used to make plastics. It is used to make medicines. And it is also added as a preservatives in your pickles. So especially the pickles that you don't make at home, you buy them out from outside, they need to be stored in good condition for a longer period of time. So they are added with vinegar. You would recollect yourself going to a Chinese restaurant and you get those four bowls on the table, wherein in one you have the soya sauce, in the other you have a Szechuan sauce, and the third one you have some watery looking liquid with chilies added to it. That's vinegar. That's vinegar. Chilies dipped in vinegar. Okay. See, lemons. Citric acid. Lemons have an acid, that's citric acid. And where do you use lemons? I'm sure you don't need much about it because you know where you use. So it's a flavoring agent. Pav bhaji, you squeeze lemon, flavoring agent. It's a food preservative. Yes. It's used for cleaning work. Please ask your parents or your mother, maybe, especially if you got an aluminum cooker at home, how does she clean it? She would be adding some lime or lemon, leftover lemons also, and then just giving it a whistle, and you'll find the inner version of the cooker cleaning agent. It is used in cosmetics, face packs, lemon colors, they smell also. Medicines, yes, and as a disinfectant. Should I give you an example? The Lysol disinfectant. Lysol is a brand, of course, but the disinfectant over there, yellow color, yet yellow as in lemony taste, that is again citric acid. All of us like grapes. Let it be green, let it be black, let it be red. That grape has an acid called as tartaric acid. Okay. Where else do you recollect tartaric acid? Which other food item do you remember? We have done it in our activity wherein you know there is a tartaric acid. Grape is one example. You remember bher, you remember SPDP chutney, that is chinchachi chutney, that is tamarind, that also has tartaric acid. You remember kairi, unripe mangoes, that also has tartaric acid. So when I'm referring to grapes, it is used in the brewing industry. Again, a flavoring agent, good to taste, no? It is used as an antioxidant in a lot of creams for tanning effect and all those things has been removed. In leather industry, it is used in silvering mirrors. This tartaric acid is of great importance. All these acids that we have seen right now, they're 100% natural acids. They're natural acids. Except for, think, tell me. Let us see few more natural acids. Lactic acid. See the picture? Curd. All of us love to eat. Maybe some of you don't, but majority of us do like. So that is lactic acid. It is used where? Cosmetics, pharmaceutical means medicine making industry. It's a food preservative for some ingredients, for some recipes. It's a very nice flavoring agent and it's very good for your skin. Try applying some curd on a regular basis. You'll find your skin becoming soft. Next one, oxalic acid. Oh, leafy vegetables, spinach. Some of you like it, some of you don't like it. But whatever, it has an acid. This again is a natural acid, oxalic acid. Where is this oxalic acid used? It is used in laundry. Now don't, when I'm saying about uses, it doesn't mean that I'm going to run with a spinach in my hand to the laundry and get that stain removed. No, but the acid ingredient is extracted and then it is used. It is used in laundry to remove rust or ink stains. It is used in the textile industry, textile as in cloth industry, as a dyeing agent, and more of its uses you'll find it as you grow up. The next one, formic acid. Look at the picture. It's an ant. Yaks. No? That ant has a formic acid inside it. Okay, and that is why when the ant stings, no? Sometimes when the ant stings, you get a swelling. Not all types of ants, bigger version, Mungra Jalamantropal. You get a big sting, and then sometimes maybe your grandparents at home or maybe your parents also would often tell you, oh, there's nothing to worry even if there's a swelling over it. Just go and apply some soil, and there is a specific soil which they ask, tulsi mati soil, in which that tulsi plant is growing. Now tell me why. Ant sting is acid. So what do you think will neutralize? What do you think would be the nature of that soil? Somewhat basic? Yes. So coming back to formic acid. Formic acid is used as a preservative and antibacterial in livestock food. Livestock means cattle, cattle food making industry. Pesticides, yes. It is used in tanning industry, leather processing industry, and in electroplating. Now, all these acids that we have studied so far, formic acid, citric acid, lactic acid, oxalic acid, and ascorbic acid, they are all natural. Okay, they are all natural acids. Do you know that even we as in our muscles, can produce lactic acid? Have you ever got up from bed and have a cramp in your calf muscles? That is because you did a lot of exercise maybe a day before yesterday or yesterday, and then at that time to generate that energy your muscles had an overshift, overwork, overburdened, and at times they had to respire, and because of that respiration at a cellular level that happened in your muscles to give you more energy to continue your sport with the same vigor, there was production of this lactic acid as a side product, and that remained in your muscles, and that is the reason why you're getting cramps. Let us see what are bases now. Basically, they all are bases. We are using these things in our day-to-day life without realizing that they are bases. Let us see what they are. Lime water, not lemon water, lime water. It is industrially chemically made. Its chemical formula is calcium hydroxide. Okay, you need not worry about its symbolic formula. You can remember calcium hydroxide as it is. And why is it used? It is used to make water soft. and reduce the acidic nature of that water. So whatever, especially the industrial water that is being left out in the rivers or the nearby water bodies, before they are let out, they need to be treated with lime water so that they become less acidic, and then that can be easily, safely being left out in the reservoirs. So that's lime water. See the window cleaner that you have, that is ammonium hydroxide. It's a base, again, ammonium hydroxide. This, other than making window cleaner, it is also used to make fertilizers, because that ammonium, that is ammonia, it is very good for soil and it improves fertility of the soil. Do you know ammonium hydroxide is also used in meat hamburgers, and they are used as cosmetics in eyeliners or mascaras. For those who are using it, beware, you are actually applying a basic substance to your eyelids. Every day we clean ourselves using different types of flavored, fragrant shapes, designs, transparent soaps at times. So these soaps are nothing but a base. It's a sodium or a potassium hydroxide. It's a soap. Okay. And that is why, in case it goes in your mouth, see what happens. It will taste bitter. It becomes slippery if there is soap in your hand. Your hands feel that slipperiness. That is because it's a base. Sometimes we have a bad stomach and we've got a lot of indigestion, and then at times doctor will ask you to take some this pink color liquid. Most, it's marketed as Gelusil, that's a name, but what it actually has is magnesium hydroxide, or milk of magnesia is what we call it as. Now why it is there? Because it reduces acidity in your stomach. So if it is going to reduce acidity in your stomach, it has to be a base, so that it will go inside your stomach and react with the acid and neutralize it. Remember, neutralization, this is happening everywhere. Acid and a base are giving a salt. So basically all the above things that you see on the slide are bases, or are basic in nature.